Hello, welcome back to Blender Sushi Live Noding. In this video, I'm gonna touch on the vertex displacement once again, and we're gonna do it the correct way. So when we are displacing like a vertices of an object, remember that we can push it based on the original position of the vertices, or we can also push it outward, inward based on the normal of the vertices. So that's actually very important. This is actually talked about in one of the Sverchok Github forum here. You can have a look. Just find this one, and then there's some example here as well. You can just have a look at the diagram and you can follow it. So it's rather simple. I'll show it to you right away. If you were to do it using Blender itself, Blender modifier, you can simply, if you start with a box, you can simply use modifier. And first of all, you might actually want to add some subdivision. And you have two ways to do that. So this is a subdivision with a Catmull Clark. It gives you this kind of result. If you give it a simple, you still get the box shape. And if you want to displace it, you use use the displace modifier and just assign it like some kind of noise pattern, and that will work right away. So there you go, and then you can kind of you know the drill. You just give it some kind of texture coordinate, and you can displace the object. So let's try to do this using Sverchok. Let's delete everything. I'm gonna use Susan Head for now. Go to compositing, switch to Sverchok. There's a new ability of Sverchok. It's like a small macro that you can call. There are a bunch of examples here. There's a useful one to grab whatever objects being selected, bring it into Sverchok. Just like one click, you get these two nodes and everything's connected. So I think that's kind of useful, and I want to show you that. Okay, so we have the original object, and this is the Sverchok kind of viewer. If you just want to randomize the vertices, you can just use randomize input vertices. That's easy enough, but that will easily turn Susan Head into a mesh. You probably don't want that. I'll save it to Vertex Normal, Vertex Displays. A better way is actually to use the normal of the object, and there is a node for that. Just type in normal, and we should have. There are actually two. There's calculate normals and vertex normal. Calculate normals is probably the new one. So plug in the vertices, edges, polygon, and you should be able to get the face normal and the vertex normal of this object. So if you use vector math, just add, this is the original position of the vertices, and this is the vertex normal of the vertices. Just add them together, and you should get Suzanne being pushed. Of course, the vertex normal is, we need to adjust the strength, so we want to use a multiply scalar. So that's one way you can do this. And you can also use move. Move node actually kind of similar to the one we have above. I might actually give this example, and there's the color or something. Well, this is one way to do it with add and scalar and plug in the normal there. But you can also do it this way. Plug in the vertices and get the normal once again. Calculate normals, vertices, edges, polygon, get the vertices normal, and plug it there. It's practically the same thing actually. And if you want to have some kind of variations, you can play around with this multiplier. There is we already have like noise, vector turbulence, all kind of nodes that can disturb the vertices procedurally. These guys actually generate values on the fly based on the vertices or vectors value. So you just plug that in there, plug this into the multiplier, and you should get like a Perlin noise kind of push. And if you use this on the turbulence, you get a different result. Turbulent is actually, of course, more turbulence. For now, I will use noise. With the noise, we can have two more control if we actually plug in vector math with multiply scalar. So here and there. Oh, actually here you just need a normal math. So there you go. That's how you control the Perlin noise on top of this original mesh and kind of pushing the vector normal. It's pretty simple, and don't be afraid of all this connection. Once you have this, you can just save it, and this is like a displace modifier, more or less. Save this node and just reload it when you need it. So it's gonna work with any kind of mesh. Actually, I'll try the torus and drop the monkey and grab the torus. And we have a new result. It's actually a lot easier to see on the torus, so we can control the noise, like how the scale of the noise itself. Higher value is more random, less value, smaller value, you get like a smoother kind of noise. And what's nice about this is you can use your own mesh as well, like being generated on the fly inside Sverchok. Before I do that, let me think. You can also do one more thing, like if you move the original vertices using move node, let's say in the x-axis, and maybe use a frame, you will see this result. We can multiply. I think plugging it in the z-axis usually give the best result, like a more interesting result. You have this classic like a wobble. You can hide the point if you like. So a lot of possibilities here. I'm just showing the basic one, like vector turbulence and all those. Like I said, you can also use your own mesh. Let's use the icosphere, for example. You just need to pipe in the vertices and plug this guy there. Edges, polygon. The icosphere is probably not the best example. Let me see. Did I forget something? There we go. We have icosphere. Let's increase the subdivision and increase the scale of the noise. And there we go. Pretty powerful, pretty simple as well. So you can choose vector noise or vector turbulence. Choose your own noise. And plug in your original mesh or the object that's already in 3D scene. So yeah, a lot of options. Okay, that's I guess pretty much it for this live noding. If you have any feedback, suggestion, let me know in the comment section below. Thanks again for tuning in. I'll see you in the next video. Thank you.